Okay, so I think we're ready for example number 4. It's on page 20. Everybody's on that page, I hope. Now it says here, sketch a possible graph of a cubic function. Okay, it's already telling us it's going to be a cubic function with a negative leading coefficient, a 0 of 5. I'll talk about 0 of 5. Okay, multiplicity 2, a 0 of 3, multiplicity of 1. Okay, those are like, this is kind of like a detective work. We're trying to figure out, what are the clues to do this. Now, it says here, cubic function. Cubic function. So that one is an odd degree. Okay. To be specific, that's degree 3. Degree 3. That means the exponent, highest exponent in a polynomial function is 3. Okay. Now with that in mind, because it's an odd, you're probably already thinking, okay, it's an odd polynomial function, then that means one arm is going up, the other arm is going down. Okay, but then which arm is up, which arm is down? That's okay. So what's our next thing here? It says here our negative, we have a negative leading coefficient. Okay, well that kind of answers our question, right? If it's a negative leading coefficient, then we know that our polynomial function graph would be coming from, it's a negative leading coefficient, so that's going to be going from quadrant 2 to quadrant, and ends in quadrant 4. Okay, is that good? Okay. Is everybody okay with that one? Yeah. Because here it's an odd degree, so we have two possibilities. We could either be quadrant 3 to quadrant 1, or the other, so the two arms are in the opposite, right? And then this one here is quadrant 2 to quadrant 4. Now this one gives you a positive lead coefficient. This one is a negative lead coefficient, so it has to be this one. Okay, so that's going to be quadrant 2 to quadrant 4. Is everybody okay with that one? Yeah.
When we are saying quadrant 2 to quadrant 4, does it mean it doesn't pass through quadrant 3?
It can still pass. We're talking about the end. Where does the end go? This is the end behavior, like the arms. Yeah, it could still go to quadrant, certainly quadrant 3. It could also go to quadrant 1, but we're talking about the end part of the graph. Yeah. Okay. So far so good? Yeah? Okay. Now it says here, a 0 of 5. Okay, well, we didn't really talk about 0. We actually called it x-intercept. The 0 of the function, is the x-intercept for the graph. So this one here, 0 of the function, that means they also tell us that the x-intercept is at 5. X-intercept at 5. And now multiplicity 2. Well, what does a multiplicity of 2 look like? That means exponent 2. This one here, a 0 of 3, so that means that there's an x-intercept at 3. Multiplicity of 1. So what is the possible graph? Okay, let's take a look at possible equation first. So the possible equation would be negative leading coefficient, so we know it's going to be negative. Okay, and then the first x-intercept is at 5, so it's going to be x minus 5. Multiplicity is 2, so it's 2. And then here, x-intercept at 3. It's going to be x-intercept at 3, x minus 3. multiplicity of 1. So if I'm just gonna put 1 there.
We have to write
Yeah,
the one.
yeah. You can write down the 1 for now and just kind of gives you an idea of, oh, what does that, where did that 1 go, or where does the 2 go?
X3 because they're no, it's cube.
No.
It should be minus x cubed at the end because it's a negative coefficient and it's a cubic function.
Okay, sorry, come back again. What are you asking?
Because it says it's a cubic function, so it's in the third degree, so we have x exponent 3 somewhere. Is that just the x squared minus times x1 equals?
Yeah,
Okay.
that's right. If we add up all of the exponent, because there's a times, right? This is gonna give us an x squared when you expand it, and then this is just gonna give you an x squared times x will give you x cubed. Okay, so here's what's a possible graph? Okay, x-intercept at 5, so 1, 2, 3, 4, 5. And then an x-intercept at 3, right there. What do you think what's a y-intercept here? What's a possible y-intercept? So this is one of the possible equation. What's a possible y-intercept? So that's going to give you 25 times negative 3, so that's negative 75, and then so that's going to give you positive or negative? Positive 75. So positive 75. So we're going to put here positive 75 there. This is a sketch. Okay. So those are some of our critical points. We have to take a look. Well, how does it go, right? Do you remember there's a bounce there? Is there a bounce? Where's the bounce coming from? At 5. Okay, there's a multiplicity of 2 there, so there's a bounce at 5. So it's going to be starting in quadrant 2, right? And then it falls down here. Okay, so it's going to be coming here. Okay, coming there. And then the 3, because it's a multiplicity of 1, it just crosses there. No fancy thing there, right? And then it has to come down, but it also has to come back up, because if it goes down, then we won't be able to reach the 5. So it goes up, multiplicity of 2 for the 5, so it just bounces down. So that's what your graph looks like. Okay, and this is a sketch. So arrow on both ends. Is that okay?
Did you give it the S shape of the y-intercept?
No, it shouldn't have S. Yeah, shouldn't have an S shape there. It just kind of goes down. This one is no S shape there. Straight through, bounces up here. Is that okay? Good. That was a not so bad one. Now let's take a look at example 5. Now this one here, write a possible equation for a quartic function. Okay, what does that tell you?
My sister started the other day and she wanted to know what she can get for work. She couldn't make it today. Oh, who's your sister? Jennifer. She hasn't started yet. She just wanted to see what she can get for work so she can work on it tonight.
Yeah, can I just finish this one? And
Yeah, for sure.
What's your sister's last name?
McFadden. She's
Is
in
it
the
for
first period.
essentials? Oh, okay.
Yeah.
Oh, so that explains it. Like
Yeah.
okay, yeah, give us a moment.
I'll
And
just
then,
wait here.
fantastic, thank you.
Yeah.
Okay, so this is a quartic function. What does that tell you? fourth degree, right? So this is going to be degree 4, okay, which is an even degree. So the even degree should give us, oh, we're actually not graphing, so we don't care about the graph right now. The 0 of 3, multiplicity of 2, and a 0 of 1, multiplicity of 2. Okay, what's a possible equation? So y is equal to, okay, the 0 of 3, so that's going to be x minus 3, multiplicity of 2, so 2. And what's the other one? X minus 1, multiplicity of 2 again. Does that add up to a quartic function? Yeah, because it's exponent 2 and another exponent 2, that's the 4. And they didn't say anything about leading coefficient, so I'm thinking positive, right? And can you see here, it's called a possible. So this is not the only possible thing, right? They didn't mention any other stuff. Is that good? Yeah?
So there is other way you can write. That's what you mean for.
Yeah, there's other way. The other way would be, they didn't mention any leading coefficient. They didn't mention any specific points. And that actually leads us to the next one. Okay? So let's take a look at your paper here. Those are described in words. This one is actually a picture. Okay. Is everybody okay? You have this sheet. We are now going the other way. So here's a graph, okay? What we need to do is we need to think about the x-intercept, some kind of multiplicity in y-intercept, and then the a value, which is the leading coefficient. Lead coefficient. Okay. Any thoughts right now? Is this an odd degree or even degree? Odd. Yeah, it's an odd because the arms are not even. One is up, one is down, right? Okay. This is going to be an odd degree. The odd degree. Okay, what do you think the degree is here? What degree? Degree? 3. Yeah. Right? Because as you can see here, there's an x-intercept there. It just went straight through. So that means it's a multiplicity of 1. There's an x-intercept there. It's straight through. Multiplicity of 1. And then the same thing there. Okay. Good. So what are the x-intercepts here? Okay, x-intercept are -4, multiplicity 1. What's the other one? -1, multiplicity 1 as well, and +2, multiplicity 1. Okay. Now, because it's an odd degree, what do you think the lead coefficient is? Is it a positive lead coefficient or a negative lead coefficient? Positive lead coefficient, right? So we know that lead coefficient is positive. We don't know exactly what it is at this time. What else do you know? Oh yeah, the y-intercept. What's a y-intercept? Y-intercept is at -8. -8. Y-intercept is -8. I'm actually going to before I go do that. We need to figure out the equation, right? We know that the lead coefficient is positive, but we don't know positive what. Is it +1? Is it +2? Is it +3? +1/2? We don't know. So what we need to do is to calculate the lead coefficient. Okay, so y equals to, we don't know what the lead coefficient is, so we're going to call it A. What's the x-intercept? X-intercept is minus 4. If the x-intercept is minus 4, what's a factor? X plus 4, multiplicity 1. Yeah. What's the other x-intercept? Negative 1. So the factor is x plus 1. Multiplicity 1. It's going to be x minus 2 multiplicity 1. You know exactly what I'm thinking about. Okay? So far so good. Now, how can we figure out the A? How can we figure out the A? Well, this is what we could do. We could use this y-intercept, a point on a graph. If the y-intercept is negative 8, that means the point is 0, negative 8. Is that okay? Yeah? Because x is 0, y is negative 8. So, what we're going to do is we're going to substitute 0 for x's and negative 8 for y. So, what does that look like? Negative 8 equals to A times 0 plus 4 is 4. 0 plus 1 is 1. 0 minus 2 is minus 2. Okay. So we substituted zeros for x and negative 8 for y to solve for A. So now what's A? Negative 8 equals to 8 times negative 8. Okay. How do we solve for A? Divide by negative 8, divide by negative 8, negative 8 cancels, so A is equals to 1. So what's the function? What's the polynomial function? So therefore, I'm going to go therefore, the function looks like this. Y equals, A is 1, x plus 4 times x plus 1 times x minus 2. Okay. Okay, so far so good? Okay, let's take a look at example number 2. Yeah, bring down a bit. Down a bit more. Now, while someone's trying to finish up number 1, why don't you take a look at number 2 and write down the stuff that you know of. Is that okay? Can I move it up to number 2? Okay, what do you know about number 2? Anybody wanna?
X-intercept is 3.
Mm-hmm. X-intercepts are, okay, so we're starting off with x-intercepts. I'm gonna draw a line there. X-intercepts is 3. What's the multiplicity? Multiplicity is 1, okay.
1 is 0.
Mm-hmm. Any other x-intercepts? We're already here.
3 of them. 2 and 1.
2.
0 and 1.
Multiplicity is 1. 0. Multiplicity is 1. And
Minus 1 and 1.
minus 1 multiplicity is 1. Perfect. Good. We get 4 x-intercepts there. Okay, what else do you know?
For y 0.
Y-intercept is 0. Yeah, y-intercept is 0. What else do you know? Oh yeah, it's going to be a degree 4. So I'm just going to write it down here. Degree 4, even degree. Negative coefficient, lead coefficient, right? How do you know it's negative lead coefficient? Yeah, it's an even down, right? Lead coefficient is negative. Okay, good. Those are good stuff. Okay, what else?
It's a quartic function.
Quartic function. Yeah, quartic function. What else? Good. Okay, those are a great start. Now, what we need to do is just figure out the value for the coefficient, right? So how can you figure out the value for coefficient? So y is equals to a. We don't know what the coefficient is, but we know it's negative. Okay? What are the factors? X. OX bracket, close bracket. Okay, are you talking about for the 0? Okay, good. X plus 1. Okay, so that's for the minus 1 there. X minus 2. X minus 3. Is everybody clear on this one? No? Okay. So X, the X minus 0. Okay, remember these are the x-intercepts. So it's going to be x minus 0. Is that okay? So that's for that one. Yes? And then this one here is going to be for the minus 1 because it's x minus negative 1. It's going to be x plus 1. Yes? And then this is a factor. X minus a. The a is the 2. That's a factor. And then the other one is x minus 3 for the x-intercept 3. Yeah. How do I know? How do I know that I multiply these?
The multiplicity is 1.
Oh, how do I know the multiplicity is 1? Oh, sorry. Multiplicity is 1 because as you can see here, it just went through. There's no bounds, and there's no S snake shape.
Yeah.
Okay. So we know it's multiplicity 1, 1, 1. Just go straight through. Okay? Good. Any other questions before we move forward? That's it?
Like we know, like my question is, we know the multiplicity of 1 and 2 and 3. How can we know the 4 and 5 from the function, the graph? How we can?
The degree?
Yeah, the degree.
Oh.
Because here we guess it's multiplicity by 1 because like it's go up and down, and we know that every what I mean, right? So my question is, what if is it 5 multiplicity of 5?
Oh, okay. If it's, you mean degree of 5?
No, like my question, how, like, if is it multiplicity is, like 3 multiplicity, it's 5. How can I know from the graph?
Oh, okay. So if the multiplicity of cube,
It's like a snake of cube.
Yeah,
of
yeah.
cube.
so if it's multiplicity of cube, we know it will have the kind of like this one here, right?
Yeah, exactly.
Okay. Now if it's x minus 1 to the 5, it will have the same x-intercept, but then that one would have a more like a flatter,
Oh.
right? Yeah. So that.
Okay.
Yeah. And if it's x minus 1, that's not. It will just go straight that one right there. There's no snake. It will just.
Yeah.
Okay. Any other questions? Huh? If it's square, there's going to be a bounce.
It's just touch
Yeah.
and
Touch and bounce back. Yeah.
Do all odd increase the same?
Hmm?
Odd increase like 3, 5, 7.
Yeah. The higher the multiplicity here, the power, the more flatter it is. Yeah. Okay. Good? Any other questions? So we still haven't figured out the A value yet. Okay, we'll do that. So how can we do that? If I put 0 for X and 0 for Y, then A would be just 0, right? So that's useless. So what we're gonna do is we're gonna use this number here. There's a mistake here. This one should be +1 minus 8. So let's fix that one. This point here is 1, -8. Okay, so that means X is 1, Y is -8. So -8 equals to A times, if it's gonna be +1, it's gonna be 1 minus 0 is 1. If X is +1, then that would give us 2. If this is +1, then that would give us -1. And if this is +1, then that becomes -2. So it's going to be -8 equals to A times 1 times 2 is 2 times another 2 is 4. Okay, solve for A. Divided by 4, divide by 4. So A is equals to -2. Okay, and that's what we predicted, right? That's what we predicted. The A is negative. Leading coefficient is negative.
Well, I'm using the -1 and 8.
Okay, good question. Good question. Why can't we use 0, 0, the y-intercept? Yeah, because we used y-intercept earlier. The reason is that if y is equals to, if we use 0, 0, then that becomes those are good questions. If I put 0 for x and y, it would be 0, and if I put 0 here, it would be 0. If I put 0 there, 0 plus 1 is 1, 0 minus 2 is -2, 0 minus 3 is -3. So 0 equals to A times 0 times 1 times -2 times -3 times 0. Well, we can't figure out the A. Because A, whatever that value is, times 0 will give us 0. So yeah, we can't. That's why we're using this point here. Yeah.
So you can only use the y-intercept method when y does not equal 0.
Mm-hmm. Yeah. There has to be a different one. Okay, so what's a polynomial function? Let's write it out. So therefore, y is equals to, lead coefficient is -2. What's the other ones? X times x plus 1 times x minus 2 times x minus 3. Okay, is that good? That's the function. This is the polynomial function that creates this graph. Okay.
So whenever we have this, like this point, it's plus 1.8, we have to use this. We cannot use anything else, right?
You can use anything other than that if you know that the exact coordinate. But this is like, yeah. That's the only exact coordinate that I could think of in this picture, this graph.
So if you put x minus 0 or x plus 0, is that wrong? Instead of x, 2x? You added a 0 there, is that wrong, technically?
X plus 0?
Yeah.
No, that's not wrong.
What about x minus 0?
It's not wrong.
Yeah, so, okay.
Same thing. Oh, no, it doesn't have to be in the brackets. Yeah, you can just put negative 2x, x plus 1. Yeah, those are good questions, yeah. Good? Yeah. Okay. Let's take a look at this. Number 3. What is this, an odd or even function? It's an odd function. Okay, let's take a look at the x-intercepts first, because that will tell us the degree. What are the x-intercepts?
It's minus 1.
Minus 1?
Yeah.
Sorry. X-intercept is minus 2.
Oh, yeah, here it's not.
Okay. Multiplicity is 1. And how do you know it's 1? It just goes straight, right? Okay, good.
And there's 1.
What's the other x-intercept?
1.
1. Multiplicity is?
1.
Next. 4. Multiplicity is? So what do you think the degree is? 3. Yeah, so degree 3. Okay. Now, what else do you know? Y-intercept is?
Minus 8.
Negative 8. Okay.
And that's it.
That's it. What do you think your lead coefficient is? Is it positive or negative? Okay, lead coefficient is? Okay, is it positive or negative? Negative. Okay, negative. So it's false down. Okay, So, what can we do? Y equals to A times, what are the factors? X plus 2. Is everybody okay with that one? Because it's x minus negative 2, right? And then the other one is x minus positive 1. And then the other one is x minus 4. Okay, good. Okay, so how can we figure out the A?
0.
Yeah, so we can use the 0, negative 8, right? We're going to use the 0, negative 8 point. So let's go ahead and do that. Okay, 0 plus 2, I'll just put 2. 0 minus 1 will give us negative 1. 0 minus 4 is negative 4. So that gives us negative 8 equals to A times positive 8. So divide by 8. So A is equals to minus 1. So the lead coefficient is a negative 1. So what's the polynomial function? Y is equals to negative 1 times x plus 2, x minus 1, x minus 4. Is that getting better? Yeah? Okay. See if we can do number 4 and 5. Let's do 4. Any idea? Is this an odd or even function? Yeah.
So let us try it and then tell us.
You want to try it? Okay, go ahead. Go try it. That's actually really good. y-intercept, so just use this one that I gave you. So for that one, don't use the y-intercept because we don't know exactly if it's right there. So just use the -1, -96. That one, we already figured that out. It's going to be -1 because it's on the quadrant 3. This one, because this is the y-axis. So it's get -1, -96. Okay, I wrote down the answer on my paper. Did you get this one? The lead coefficient is a positive, right? Degree 4. Is everybody okay with this part?
Yeah.
Yeah? Okay, good. Very good. Very good. Yeah, degree 4. It's an even degree. Okay, go ahead and try the other one, number 5. So I'll write down the last one. I wrote down the answer for the last graph.
That's the answer?
That is the answer.
Sweet.
Oh, okay. worked hard today. Very, very,
I will do the function.
very well done. So this is my final answer.